Hey there, here's a video on page 4, the section 3.4 notes. So here we're talking about example 3, interpreting velocity graphs. So this is a velocity graph, and we see that there are 5 intervals we're going to consider. Again, the following graph shows the velocity in inches per minute, so those are our units, of a snail. So that probably would be appropriate for inches per minute to use those units. Moving a straight line. Describe the motion, what is the max speed, and when. So those are all things we're going to be working out in a little bit. First off, what we're going to want to do is generate a speed graph to go with our velocity graph. Remember, speed is the absolute value of velocity. And we talked about absolute value transformations in the past. What you do when you do an absolute value transformation is that all negative y values become positive. So these are all positive right now. And then this has to flip over the x-axis. So we see that at 10, it's kind of hard to read. It looks like it goes down to -9. So it's going to go up to 10, 9. Okay, I kind of missed. Let's try that again. A little better. So you can kind of get rid of all this now. Negative 10, 9. And of course, this part stays where it is as well. So that's to do an absolute value transformation of the graph off to the left. Now, describing the motion, well, obviously the snail looks like it's probably accelerating over here. Seems like the speed stays constant at this point, or that this interval, then it's decelerating, or it's actually turning around. Well, not turning around just yet, but it's decelerating over here. Then we have a change in direction. And then, of course, it changes direction over here again. And of course, you have acceleration happening here as well. But that's just kind of give you a general idea of what is happening. But let's actually go through these examples right now. Look at each of these intervals, 1, 2, 3, 4, 5. So for number 1, let me actually reduce this just a tad because I want to be able to see more of this graph. Oh. The snail starts with a velocity of 0 inches per minute. And travels for 2 minutes, steadily increasing its speed up to 4 inches per minute. So it started at 0, went to 4. So that's clearly acceleration. So I was correct about that. That is acceleration. Snail then travels for 3 minutes at 4 inches per minute. It stays at that same speed. So it's a constant speed. So there's no acceleration here. Then it actually slows down for about 2 minutes until it reaches a velocity of 0 minutes. So for interval 3, so again, this is acceleration, that was constant speed or constant velocity. Then it's slowing down. And it slows down for about 2 minutes. So it's kind of like if you're driving and you hit the brakes, right? You're still moving forward and hit the brakes, but you're slowing down. Then all of a sudden you come to a stop. So you're at rest. And this is decelerating. And at t equals 7, the snail is instantly at rest, instantaneously. Because remember, the velocity is instantaneous rate of change of position. Then all of a sudden, it turns around. It travels in the opposite direction for 6 minutes steadily. So at rest, then turns around. And it's going in the opposite direction. And steadily actually speeding up, believe it or not. Even though the velocity is negative, it is speeding up to about 9 inches per excuse me, 9 inches per minute. And then it slows down to a speed of 0 inches per minute, t equals 13. So now it's at rest again here. So also instantaneously at rest here because velocity equals 0. Now the part that gets kind of interesting is that, well, then he now travels in the original direction with a steadily increasing speed after t equals 13. So we're back to accelerating again at this part here. The part that gets kind of interesting, and that could be a tad confusing, is examining what happens between 7 and 13 seconds. But again, we are accelerating past 13 seconds. So let me get a highlighter out. So in green, the snail's speeding up. And yes, the snail is speeding up over here, just in the opposite direction. Here, we're slowing down. So it happens that when the velocity and acceleration are opposite in sign, you have a slowing down. So basically you have a negative velocity, but positive acceleration, because what's happening here is that your tangent lines are positive between t equals 10, t equals 13. And this is a tangent line for a velocity graph, which again represents a derivative, and the derivative of velocity is acceleration, right? So derivative velocity is acceleration. So the tangent lines represent acceleration, right? So whenever your velocity and acceleration are going against each other, that's actually slowing down. Likewise for interval 3. Your velocity is positive, but your acceleration is negative. Here, when the velocity and acceleration are the same sign, you're actually speeding up. So yes, we do have a negative tangent lines for interval 4, but the velocity is also negative 2. So in this case, you could say decelerating, I suppose, but it's still speeding up. It's speeding up in the opposite direction for interval 4. So to answer these questions here, for what intervals is acceleration positive? Of course, acceleration is positive from 0 to 2. And we'll do a closed interval here, but open here. And then from 10 to 14. And the reason why I do close at 0 and 14 is that the derivative was positive at t equals 0, and the derivative was positive at t equals 14. But at t equals 2, we have a corner there, and t equals 10, it's actually 0, the velocity. So, or sorry, the acceleration is 0, so it's not really positive or negative for acceleration at 10. And he had a corner at 2, so it's not differentiable at 2. And remember, acceleration is strictly a velocity. Strictly a derivative of velocity. Then when is acceleration negative? Acceleration will be negative. Looks like some people are coming into the room while I'm doing this video. That wraps up pretty soon. The acceleration is negative from 5 to 7 and from 7 to 10. So you're looking at the tangent lines again there, right? So from 5 to 7, it's negative, and from 7 to 10, also, but you can't include 7 because that's a corner there. And again, 10, you have 0 velocity, and 5, you have a corner also. So we will have another discussion about this in class about closed and open intervals, because that could be a little confusing. The culture sometimes just sticks with like open intervals for most situations because it can be a bit ambiguous. But again, acceleration is strictly a derivative of velocity. Your derivative is definitely positive at 0, definitely positive at 14, so we can include it and say the acceleration is positive there. But at corners or at horizontal tangents, accelerations, either you can't find acceleration because it's not differentiable at corners, or at 10, the acceleration is 0, which is neither positive nor negative. So speed increases when velocity and acceleration are both positive or both negative. That's when you're speeding up. Speed decreases when velocity and acceleration are different signs. Like one's positive, one's negative, or vice versa. They're kind of counteracting each other, right? So, like for example, your velocity is positive, you hit the brakes, but the car is working against your motion because it wants to stop, right? But if you turn the car around and speed up, that's still speeding, right? So maybe your velocity is negative if you consider going back home the negative direction. If you're leaving your home initially, that was the positive direction, but going back home is negative direction. But then you're, accelerating because you're gaining speed. So that's why we always want to look at the speed graph, which again looks like this, and we see that definitely you're speeding up here, and definitely you're speeding up here because that's the increase in speed. But you're losing speed here and here, right? So that's kind of what's happening there. So, and we could probably say, just to finish this off, that we're speeding up from 0 to 2. And I'll just use open intervals for that. And that's because sometimes your velocity can be 0. So I want to be kind of careful about that. So we'll just use open intervals for you're speeding up. And you're slowing down. So you're speeding up from 0 to 2, as well as from 7 to 10. And as well from 13 to 14. We're slowing down from 5 to 7, and from 10 to 13. And of course, we're constant speed from 2 to 5. So that kind of ties everything all together at the end here. And we'll practice these problems in class on Tuesday.